Welcome, everybody. Hey, you're tuning into part 4. So we are 4 weeks into our Modernization miniseries. If you missed the first 3 sessions, I would definitely recommend going back, getting registered, or watching the recordings of those sessions, since we've been working over the last 3 weeks to really build out kind of the foundation for the next 2 topics, and that is that we've covered modern control assets and software. We talked about how to put a strategy together to connect all of those given assets. We then last week spoke to modernizing the devices that connect into the control system with smart sensors, smart safety devices, and smart motor control devices. And in these next 2 sections, what we're going to do is cover today. We'll speak to visualizing actionable information. So how do you get automated diagnostics out of your control system to increase system availability and reduce downtime? And next week, as we wrap up our mini-series, we will be focused on increasing productivity. So part 4 and part 5, again, we're going to build on part 1, 2, and 3. But if you didn't catch those, hey, either way, I think you'll come out of today with some new information and something that you'll find helpful. But as a reminder, the session will be recorded. It will be provided after our live discussion here today. If you have questions, feel free to chat them in. We will also have a 10-minute Q&A at the end of our get-together here this morning. Well, let's jump into a really exciting session here this morning and talk a little bit about how we're going to visualize actionable information in the control system. All right, if you've been hanging with us for 3 weeks, this slide has come up and I've spoken to it. But I think, again, it's a great reminder as to what it is specifically we're trying to accomplish. So the goal of this mini-series is really to not only help you reduce risk, but drive towards a truly connected enterprise. And in a connected enterprise, we capture useful information on the plant floor, transform that information into something that can drive action, and leverage that across the entire enterprise. So if you're a multi-site organization, imagine, if you will, site A performing 95% to goal, and site B performing 80% to goal, but you're making the same product. Right? So wouldn't it be useful to be able to understand why productivity is higher in plant A versus in plant B? And with that level of insight, you can make more informed decisions about what production should be happening where, and exactly what that will mean through not only your supply chain and potentially in your distribution centers, but also, more importantly, to your customers. Right? So if we're making more informed decisions, you are capturing and generating more value, which you can then in turn provide to your end customers. Just like the last slide, if you've been hanging with us, you've seen this slide as well. Today we're going to really kind of dig into the information management and analytics side of the components of a smart connected system. So just a quick review here, but highlighted in yellow is really kind of one of the core components of a smart connected system, and that is intelligent or smart devices. And those smart devices provide insights into the control system. So you've got tight integration and better information from those smart devices, can extend that information up to a mobile or visualization platform. We can make more informed decisions by leveraging the appropriate compute resources at the right level of your control system. And we're able to do all of that because these devices have been appropriately connected together. So again, since today our focus is going to be around information management and analytics, we just wanted to remind you as to what we're really moving towards in the last slide, and what exactly a smart connected system is and where it fits into the connected enterprise with this slide. And we're finally hitting on a little bit more detail on these last two outcomes that you can expect when leveraging a modern smart connected control system. We've talked a lot about in our last couple of sessions around reducing risk and providing cost-effective and very simple migration and modernization strategies. We've spoken to generating greater connectivity and what that value is, but how to do that in a secure manner. And today we're going to hit in and double click on and drill down into the automated diagnostics and what we can use to increase availability. So how are we going to turn all this new useful data that's all sitting on an Ethernet IP network into something that can be used, right? And to drive better decisions and information out of your system today. There's a couple of different ways that we can get better insights into what's happening. And one of the easiest ways to really jump into analytics and useful device level information is through an appliance that we call FactoryTalk Analytics for Devices. So in our previous sessions, we talked about Ethernet enabled devices like controllers and switches, VFDs and smart sensors, right? Every one of those different technologies have an Ethernet IP address. What this analytics appliance does is captures information that exists on every one of those assets and puts it in a format that is really easy to consume. So when we apply this appliance to a given network, we give it a range of IP addresses to go scan. Once those devices are found, we generate a dashboard that represents device level detail that users or maintenance people can use to make better decisions and capture exactly what's happening in the control system. So one of the other benefits of this platform is while all of this data exists in those smart devices, it would take a significant amount of time and effort to build the level of detail in this dashboard that exists in this appliance. So we're really streamlining and going directly from the device to dashboard with literally a 5-minute setup for this device. So it's a very intuitive utility to use, to interact with. And what's really great about it is we have an app that can be paired with this device where we can push the same detail and information down to an end device like an iPhone or an Android appliance or an iPhone specifically. So here's an example of that screenshot. In this case, we've got an L75 processor selected. You can see here that a very small amount of memory is currently being used from a logic memory perspective. The utilization of this processor is also extremely low. Only 1% of its total utilization is being leveraged here at the moment. But if this device were live and controlling a true manufacturing process, we'd see this data being changed while the device is running, right? So it is a live representation of what's happening in that device at any given moment. In addition to that, if the state of this device changes, if its health is deteriorating and it is moved into, from a healthy status, as you see here, to maybe an example like up above the top line item, an ENBT module says maintenance required. we will push that notification out to a set of users defined by you so that they can then go see exactly why maintenance is required for that end device. Just one more thing to speak to is that here's a sample screenshot of the intelligent interface. So over time, as these different state changes come up, what you'll see are these action cards. So the action card user interface is really helpful, and it's also intelligent in that as you vote certain things up or certain things down, over time, the device will learn those preferred characteristics and or will rather learn those preferences of you as a user and bring the things that are most pertinent to you based on your interaction history to the top of this user interface. Now, when we talk about actionable information and visibility, one really important thing to consider is investing in a technology that provides visibility into your control system network and the health of that control system network. So the utility here that we'll speak to over the next few slides is called FactoryTalk Network Manager. And there are three primary tenets of the Network Manager software, and that is to, one, generate a network map and provide visibility into the current state of your network as it exists today. It's also an extremely helpful troubleshooting tool. So when you combine Rockwell products like Stratix switches and Rockwell hardware, like ControlLogix or servo drives or VFDs, we capture device level information directly in this platform and provide troubleshooting tools as to why the state of the network may have changed from a connection point of view. And then finally, we can maintain and configure Stratix devices directly in this platform. So rather than navigating to the device manager page, we can change the port settings of individual ports directly through Network Manager. We can also back up and maintain the existing configuration of a Stratix switch. So if a device were to fail and you replace that device with a new non-configured device, we can push that configuration directly from Network Manager to the end asset. One other thing from an automated diagnostics perspective is we've just recently introduced this capability called automatic IO Diagnostics. So if you are leveraging FactoryTalk View, like version 12 or higher, and you're using version 33 of Studio 5000, we can, in this case, navigate to the controller add-on profile. As you can see here in the bottom left of this screenshot of the add-on profile, check a box that says Enable Automatic Diagnostics. And then in FactoryTalk View, we simply add a automatic diagnostics object to a screen, and we push any and all IO diagnostics directly to this object. So the intended use case here is, if you are a maintenance person interacting with View objects or your HMI system, you can have a set of screens dedicated to identifying the state of different IO devices and quickly navigate to and understand why or what things are happening at an IO level within your control system. So super simple setup here. Again, just enable the diagnostics in Studio 5000, add an object to a screen, and we'll push that information through the FactoryTalk Events capability to this object directly. In a previous session in our networks talk, we talked a little bit about SIP energy, right? And we didn't really expand on that in that session, but here we'll take a moment to speak in detail about what SIP energy is. And so what this utility is a family of objects and services that monitor and capture energy-related data from devices that are consuming energy. So think of power flex drives, motor control devices, and of the like. And what we're then subscribing to is not only the aggregation of that energy data, but think of it as a means to manage energy as well. So the SIP energy object is embedded in our power monitor devices. So the power monitor 5000 and 1000, our PowerFlex 755 drives also have a SIP energy object directly embedded in them. Our Kinetics 55 and 5700 servo drives, as well as E300 electronic overload. So we've spoken to 3 of the 4 different technologies here in previous sessions, and all you have to do is open RS Links Enterprise or FactoryTalk Links today and add a shortcut to a given object, define that shortcut type as a SIP object, and you'll see in this case the ability to add that to any of the devices that are shown above. Once you do that and that SIP energy object is subscribed to, we can then push data to a FactoryTalk view system. You could push that data and use that data or historize that data in a way that is useful to you. So think of this as a really simple means to capture energy-related data directly from end devices. From an automatic or automated diagnostics perspective, we've also recently enhanced the embedded firmware in 2 of our high-performance Kinetics products. So the Kinetics 5700 and the recently released Kinetics 5300 simply require a firmware update and an update, in this case, to the control program or the firmware for the controller to version 33. And in doing so, we will have added a couple of really important features to those products directly embedded in the firmware. The first one is our virtual torque sensor. We've also updated our ability to provide adaptive tuning on the fly with the 2.0 release of that firmware. And we've also added the ability to provide not only one command notch filter, but now up to 4 notch filters that can be defined per axis. So the virtual torque sensor can be used for anomaly detection and analytics. So you might monitor the machine operation of a given asset and then be able to leverage that torque sensor to assist in maintenance and commissioning of a given asset. So we've got a couple of different applications here, like you might be monitoring for jam detection. You might see change over time of mechanical performance of a given system, or of a gearbox that may be failing. So as torque goes up, we can monitor that through this virtual torque sensor and then provide through a tag a simple means to leverage that information to make an informed decision about what things may need to change in the given control system. In addition to that, we've really been focused on building out more automatic and useful diagnostics in our 755T family drive. So one of the things that we've done here that is a differentiator and I think immense value add for our customers is we've started to leverage these very advanced analytics. So what we're doing in this case is we are monitoring real-time data like voltage, kilowatt hours, total running time, number of cycles, the temperature that the drive is running at, and using that information and contextualizing that in a way to characterize a couple of different conditions. So one condition would be monitoring those runtime type data formats and generating better analytics into when the cooling fan will replace or will fail rather. So since we know the stress limit of our cooling fan, and we've done thorough testing on each one of these different criteria, we can predict when the cooling fan will fail, generate that insight for a maintenance person, and then schedule downtime instead of leading to an unplanned downtime due to a fan failure. In addition, in this PowerFlex family of drives, we've made fan failure extremely simple. So this is all about reducing unplanned downtime. Here's just a quick build of that predictive maintenance that's embedded in PowerFlex drives. So a couple of example components that we're subscribing to here. What we're able to do in this case with the fans and blowers is, in the past, we really were only monitoring a timer. As I mentioned in the previous slide, we're monitoring a handful of different tags that exist in that device today, and we're able to predict with a high degree of accuracy when that fan will fail. In the future, we'll even be able to prescribe when fan failure will occur and drive that fan failure potentially out of the system over time. On the power component side, in the past, the power components have really been about protecting the device in case failure were to occur. Now we can tell you when IGBTs will fail based on the same user conditions that are applied to the drive, or the environmental conditions applied to the drive over time. So we're able to predict when power components will fail in 755T class drives. And we'll be extending these capabilities into future releases of PowerFlex drives. This has become a really useful set of information that will be applicable to not only the 755T, but also to the upcoming enhancements to multiple portions of our PowerFlex family. So those were a couple of different ways that you can really increase the use of information and drive towards more actionable type activities. So hopefully you saw there that there's a lot of information that exists in those assets that were previously covered and potentially invested in. And the whole goal here was to leverage those automated diagnostics to help you drive downtime lower than you've previously experienced.